All right, let's get started. Hi everyone, and welcome to our live demo of how our Alooma Data Pipeline works with the Snowflake Data Warehouse. My name is Jason, and I will be co-hosting today's webinar. Before we jump into things, a couple of admin items. Firstly, feel free to submit any questions during the presentation. I'll be keeping track of these for the Q&A session towards the end. Also, we're recording this webinar, and we'll be making it available tomorrow with the slides. So don't worry about rushing and taking notes. All right, let's get started. So today you'll hear from Yair Weinberger, our co-founder and CTO. He has been with Alooma for the last 3 years and has also been involved with data pipelines for the last 15. Today Yair will do a deep dive of the Alooma platform, including native and custom integrations, schema management, safety net settings, and more. He will also run through a live demo to show you how easy it is to set up and manage. So without further ado, I'll hand it over to Yair to get us started. Yair?
Thank you, Jason, and thank everyone for listening. When looking at data, Snowflake coined the term the data struggle end. And when we are asking ourselves, what is this data struggle? Essentially, we start with all of our data in disparate silos in all of the different data sources on the left side. And our goal is to enable our entire organization to utilize and use this data, normally using BI or analytics tools, but also using applications. And the path to get this would be to get all of the data to a data warehouse such as Snowflake, and then use some kind of a data pipeline to move the data over. Alooma, Snowflake have made great strides in making the data warehouse part accessible and easily manageable in the cloud. So Snowflake is a data warehouse as a service that is taking away all of the load from managing and maintaining a data warehouse. However, the task of moving the data from all of the disparate silos into Snowflake still remains very difficult. And what we see is a lot of the time of data engineering and data teams is being spent on this ETL pipeline, and on not only writing the first version of a script that would move the data over, but also maintaining that over time and maintaining data integrity and data freshness over time. And we have spoken to hundreds of different data teams. All of these teams told us the same thing. We are building it in-house. We are using all kinds of homegrown scripts and open source tools in order to build it, and it's very slow. It doesn't scale, and it oftentimes also loses data. And this is where Alooma comes into play. Alooma is trying to solve the main challenges of building data pipelines, and this could be how to get the data exactly once and not getting any duplicating data, how to handle errors gracefully, and how to manage the changing schemas and changing data over time. With historically, when we look at building software companies, in the past, when we wanted to start building a company, we would look at cooling, at AC, build a server room, and only then we could even start working. We had to deploy our servers. Today, everything moved to the cloud, and we don't think anymore about how much power does our hardware take, or we don't even care which hardware does our virtual instance runs on. All we care about is these are our access pattern. We need this amount of RAM, this amount of CPU, this amount of storage. It is being provisioned for us in the cloud. And the same has actually happened with application servers, with abstraction layers like Docker and Heroku, where all we do today is wrap our software inside a container and ship it to the cloud. We don't need to worry about installing the operating system or collisions between different applications. However, whenever we go to data, we are essentially 15 years in the past, because the first thing we need to do is we need to think, hey, which database do we need? Which data warehouse do we need? Then we need to deploy it, to maintain it, and to build the pipes that connects to it. This is where Alooma comes in. Our goal is to abstract away this layer, to abstract away the data pipeline layer that enables to get data from any data source into into Snowflake in this case, but any data warehouse for that matter. And Alooma enable companies to use their data by letting teams integrate, enrich, and transform the data on the way, and then load it into the data warehouse of their choosing. So what is a data pipeline? And again, we described the data sources that are different. We categorize the data sources to four different basic categories. One category is just could be flat files or log files. They could be CSV. They could have many different formats. The other one is events, event streams, and these event streams can be instrumented from mobile applications, from web applications, from IoT devices, but basically anything that just tracks events and sends them over. Then we have the transactional database. So we have microservices or application inside our organizations. Each one has its own state. The state can be managed in MySQL, Oracle, Postgres. All of these are transactional databases that enables our applications to do operations like create, update, and delete. And of course, in order to run analytics, they're not designed for analytics. So in order to run analytics on this data, we need to port it over to a data warehouse such as Snowflake. And then the fourth category is a different SaaS vendors, because today many of the things we do in our organization we don't build in-house. We use a third-party vendor that is providing it as a service, and it could be Salesforce, Marketo, Zendesk for support, Stripe, or Zuora for billing or payments. All of these hold their own data in their own silos. And again, we want to have this data accessible for analytics and for other applications inside our data warehouse. Alooma is the way to get that over. So Alooma would connect to any data source, would be able to extract the data from it continuously, and then move it in near real time to Snowflake. What does Alooma have under the hood? And I'm going to dive a little bit deeper in a demo to actually show how it looks. But under the hood, Alooma has a message queue, and this message queue serves as a persistence layer that will get all of the data from all of the different sources into a message queue. We use internally under the hood Apache Kafka, just because it's a really good one, but there are other options as well. Once everything gets into the message queue, it goes through three different steps. The first step is a code engine, which means run any code on the data, transform it or enrich it. And I will go through some examples of what can be done with data. And these transformations can be on a per event basis. So we can take one event every time and transform it or change it. Or we can actually aggregate events that come in different times. So we can have things like a sliding window where we want to perform aggregates on how many sales did we have in the past hour for each geography, and then spit out the aggregated result forward. The code engine is actually the heart of the data pipeline. It enables if the data does not need any processing, it could just go through. But if any enrichment or transformation needs to be done on the data, this is where it's being done. The next step is the mapper, and the mapper is responsible for schema translation and evolvement. So sometimes the data has a schema in the source. The data that's coming from Salesforce or MySQL has a very strict schema that the source holds. In that case, the mapper will take the schema from the source, will translate it to Snowflake, because not all data types match, of course, or again, any other data warehouse, and we'll just move the event over according to the schema. Some data sources, let's say we track events from a mobile application, they don't have a schema. They can be a free-form, semi-structured JSON, Avro, or any other format. But the schema needs to be inferred from the data. So what the mapper will do in that case, it will look in the data itself, and it will infer the correct data type in Snowflake from the data that's actually going through. The most important part is how to handle errors, and this is the Restring Q. So anything that cannot be pushed through correctly to Snowflake, and there can be many reasons. Maybe you just pause your data warehouse, which is an option. Maybe the data type have changed and it can no longer fit into the table. Maybe a rogue event came in with bad format. All of these can effectively, when building a data pipeline in-house, can effectively pause and halt the entire pipeline until a resolution is being made. With Alooma, all of these errors are gracefully collected and being put into what we call a Restring Q. In this queue, it is possible to search the errors, to filter them, to analyze them, to fix them, and then to ship them back into the data pipeline. The last part is how to actually load the data in, and this is in itself not a very easy challenge, because with high data throughput and data warehouse like Snowflake, you should always batch copy the data into the data warehouse. And then there is a fine balance between how to get the data as fast and as fresh as possible, and on the other hand, how to not overload the data warehouse with too small batches. And Alooma there dynamically allocates the correct batch size and dynamically adjusts itself according to the actual load on the data warehouse. So if the data can come in fresh and fast, it will just come in. If the data needs to be delayed because the data warehouse is overloaded, then Alooma will delay it. Under the hood again, and this is especially when comparing to building a data pipeline in-house, there are some things that are very hard to achieve when building it in-house. And the first is, of course, integrations. These are almost table stakes when building a data pipeline. You need to build integrations and APIs and connect to the APIs of all of the data sources that you want to build in. Some could be very simple, just as performing a REST request every few hours. Some can be very complex and have a very complex APIs and integration. And we have built in, and we have dedicated teams that already invested a lot of time in developing this connectors and API to all of these different data sources. Then Alooma enables real-time access to the data. And again, this is something that is very rare with homegrown pipeline. Getting the data in usually normal latency with Alooma is 60 seconds, but it can be anywhere from 60 seconds to a few minutes, depends on the load on the data warehouse itself. Another point when trying to build data pipeline in-house is that at scale it usually breaks. And as the business grows, as the scale grows, it's getting harder and harder to maintain the same properties of the data pipeline at 10x or 100x scale. Alooma today already runs 100 of billions of events per month across its customers, and it can scale up virtually to no limit. The last thing that's really missing when building something in-house is data security. And we've seen many companies spin up a Kafka cluster, then use Kafka streaming or Apache Spark in order to build their data pipeline. And then effectively every developer in the organization at this instant have access to all of the data and can do whatever they want. Alooma can segregate user access, provide data governance, and of course also conform with industry standards like SOC 2 Type 2 compliance. Let's go to actually looking how it looks, how Alooma looks with Snowflake. So I'll just want to make sure that my screen is still visible. All right, so what you see here is actually the first thing when going into Alooma, and this is already a deployment that has some data sources in it, just in order just for the demonstration. But normally it will start empty, and everything on the left are the different data sources that are being ported into Snowflake. Of course, we can click on any of those. We can actually see live samples that came through the pipeline. Did they come correctly or not? What was the actual content? How has this data been flowing in the past 3 days or 7 days? And of course, change or modify any settings to our integration. If we want to add an integration, let's say we want to get a MySQL database and port it over to Snowflake, it is as simple as a few clicks. We would add a new input, go to select MySQL from the 100 of different integrations, and just provide the credentials to Alooma to connect and decide on the mode of connection. And Alooma can actually track the transaction log of the database and get any sort of a change data capture in a change data capture way and get every update. Or Alooma can just do a fully dump of the entire data set every interval. It really depends on the size of the data, on the replication properties that are required. But we will support it all. Give a list of tables or just leave empty to replicate all tables. And then choose where do you want it in Snowflake and click Finish. Once you do that, the data will start streaming. And we actually have two modes here of replication. The recommended mode and what most of our customers are using is the one-click mode. And this is basically saying, look, just do your best in mapping my data and moving my data over into Snowflake. Take the schema from the source, apply it on the target, and do any transformation that are required on the data itself. On the other end, you can opt for control, for more control. And opting for control means I want to use a manual mapping. I want to map myself, and I want to decide myself how the data is going to go into Snowflake. The manual mode is really useful if you already want to map into existing tables or existing data sources, or moving from an homegrown replication that already replicates into existing tables into Alooma. And once we added the data source, the data starts streaming almost immediately. The next step in the pipeline is the code engine, is the Alooma code engine. And the code engine is the ability to run any code on the data as it goes through. And there are some examples here to go over. The code engine can actually get live samples from the pipeline, can run a test on them. Of course, all of this is accessible via APIs and can be used for continuous integration purposes. So the code does not need to be edited in the browser. It can be edited in the IDE and just pushed through once all tests are passing. So interesting thing that can be done, maybe just splitting an event into different ones. Let's say we have a data source that we want to split to several different tables. So this is a very useful way of doing it. Just discarding some of the data. For example, we might have some PII data or some sensitive data we don't want to port over. We want to discard it on the pipe. We don't want the data warehouse to have access to it. Then we can just discard it. Enrich with geo-IP information. Enrich the event with geo-IP information. So get an IP address that is coming from events and just enrich it. And any logic that you can think of in Python, you can write here, including, again, like I mentioned earlier, stateful processing that needs to actually relate to past events as well. Once the events are through the code engine, they will make their way to the mapper, and the mapper would be responsible for translating the schema from the source into Snowflake. So as you can see, it decided this column is a date. It will create the appropriate data type on Snowflake, and the data will start streaming. If the data is not nullable in the source, it will also be not nullable in the destination. One interesting thing that Snowflake has that is very different from other data warehouse is the ability to load semi-structured data directly into a column. In Snowflake, this column type is called variant. So let's say we have nested JSONs in our events, similar to the metadata field here. Right now, it's mapped into a flat format, which means every inner field will have its own column or discarded, like the gray ones. However, you might want to choose to just map the entire JSON object into variant. And this is especially with data where the structure is unknown upfront. It's very useful to map it into variant with Snowflake. Then I would just choose variant as the structure, and then the entire object will just go into one column. Alooma by default will map any one level nested JSON and up into a variant column, and these are the best practices also recommended by Snowflake. In case of data that does not have schema in it or does not yet have schema, Alooma can actually automatically determine the schema from the data itself. So Alooma will look at a field, would look at the values, and again, with a click of a button, and in this case, I actually chose manual to be able to show this. With a click of a button, it will determine the data type itself. So for example, with this field that contain numbers, it will select a number data type. With other field, it will select a varchar data type. With a field that has not floating point numbers, it will select a float data type. And of course, all of these can be changed or modified before applying the changes in manual mode, because manual mode is basically means full control. One other interesting thing to remember is the Alooma safety net. The Alooma safety net allows, like I mentioned, what we call the Restring Q, allows any erroneous event to be analyzed later without halting the pipeline. So in this case, you can see my data warehouse was paused. My data warehouse was paused, the data could not be loaded. It's okay, it would be put here in the Restring Q. I can actually filter, okay, let me find everything where my data warehouse was paused, and it will just filter these errors. Once I want, I can even get the samples of the event that actually caused the issue, and then I can choose either to restring everything back into the pipeline, edit it in the code engine, so go to the code engine with this sample in mind, or modify the mapping. For example, for errors like no mapping, the resolution would be to just modify the mapping, obviously. So I could go here, click on the mapper, and I would actually get to the mapping with the specific unmapped event type that I need to fix. So trying to make it very easy and very simple to handle errors that obviously will occur in the pipeline. Alooma provide dashboards and metrics just to show what's going on with the pipeline, what's the status of the pipeline, what's the latency, how many events are being loaded, how many are actually discarded, what the status of the Restring Q or the error queue, is it growing too big? And again, of course, how many events are in the incoming queue, or the Kafka queue that receives all of the events. And of course, all of these metrics, again, and notifications are accessible via API, so they can be hooked into any other monitoring tools. Some of our customers already have implemented Datadog integration and even Slack integration for notifications and alerts. Another safety net on top of the safety net is the ability to write all of the raw data into S3. So Alooma actually holds a separate pipeline that will get the event from the incoming queue and just write them into S3 just for safekeeping. So even if something, let's say a bug in the processing logic caused to load bad events into Snowflake, you can always go back in time to any time period that you want and load the data from S3 back into data warehouse and run any computation. So you can change the code engine, go back in time and run it. Alooma also provide a live view of the data itself. The live view, I'm hoping that it will go well over video, but this URL is actually publicly accessible, alooma.com/live, to play with. It would actually show the event flow in real time and where are they coming from. I can even click and look at specific samples, or I can filter if I just want to look at my page views. It will immediately show me that my page views are only coming from the mobile SDK and not from the other two data sources. And I will only see samples that are satisfy this filter. So to sum up this demo, Snowflake is a great data warehouse for companies moving to the cloud or born in the cloud that want a managed service for data warehouse. And Alooma is the best data pipeline in order to get the data from wherever it resides, on-premise or SaaS vendors, into Snowflake.
Great, thanks so much, Yair. So if you haven't already done so, please send us some questions in the chat panel. But it looks like we've actually got a few. So let's get started with the questions. Looks like the first question is, how fast can Alooma replicate data from PostgreSQL into Snowflake? And can data be available within seconds?
The answer is yes. Data can be available within seconds. Alooma can, again, similar to MySQL, Alooma can replicate Postgres in a similar fashion by reading the transaction log or the write-ahead log. Alooma has what Postgres calls a logical decoder that can be installed on the Postgres server and then ship the transaction log, and this is almost instantly or very near to real time. Now, in terms of data availability in Snowflake, seconds is definitely possible. It does depend on the data throughput because Snowflake, again, does not support or does not like at least inserting every row separately. So Alooma will be using micro batches into Snowflake. If Snowflake can accept a micro batch every 5 or 10 seconds, which again depends on mostly on the data volume, on the number of changes that happen on the Snowflake database, then it will be available within seconds. From our experience, usually a realistic expectation would be 30 to 60 seconds with that part with Snowflake.
Great. All right. Second question is, what are the different code engines supported? Or maybe more specifically, what are the different code engine languages supported?
Yeah, that's a great question. Right now, we only support Python. And Python is a very robust language that can do a lot of things. We are working on adding support for more languages in the code engine, but at the moment, Alooma supports Python.
All right, awesome. Third question is, how do I load incremental data, data from the source?
Yeah, so the way Alooma works is any data that needs to be upserted. So of course, a data upserts that we know from the transaction database does not play well with analytical data warehouse like Snowflake or Redshift or BigQuery. So if the data has updates or it needs to be changed, what Alooma does is I would actually show that. Alooma would load the data into a staging table. And then from the staging table, it will be merged into the final table as well, while retaining only the most recent version of each row. So let's say a row had an update or 5 updates. The staging table will have 5 versions of this row, but the table itself will only have the most recent one. And Alooma also provides a new real-time view that merges the staging table and the final table on the fly. So in that case, for example, the salaries table, it's coming from MySQL. So you can see, if you see my hover, it goes into salaries log, which is the staging table, and then being consolidated into the salaries table. And there is a real-time view that enables real-time access to the data as well. With Snowflake, actually, they support what they call a merge operation. So this is actually a very efficient merge, a very efficient way to merge data from the staging table and the final table. But we actually have a little bit more complex way to do it, but it works also with Redshift or BigQuery or databases that does not support merge operations as well.
Okay, next question is, when restarting data load because of a mapping error, is it possible for data to load only for the failed records, or do we have to load the entire data load?
Yeah, so that's exactly the point of the Restring Q. The data is only reloading for the failed record. So every failed record will go into Restring Q, and only these will go there. So the data load does not need to be restarted. All of the data except for the failed record is already available, and then the failed records will just be loaded on top of that.
Okay, next question is, are initial seeds parallelized? For example, if you have a table of 100 gigabytes, is a load executed in parallel?
Yeah, so again, it depends. It kind of depends exactly on the use case. So let's say we want to load or where the data is coming from. If the data, let's say we have a table of 100 gigabytes that we want to port over, the loads are definitely executed. So every time Alooma will load a batch, and then it will process the next batch while the batch is loading. Every batch we are using Snowflake way of parallelizing the load itself. So we would copy the data for this table into different files in S3, and then issue a copy command in Snowflake that can parallelize the load across different nodes, because it's using the fact that the data itself is spread out on different S3 files.
How is scheduling managed?
Yeah, so Alooma has a scheduler, and this scheduler can support running a SQL query in the data warehouse itself. The scheduler itself is currently available via API only, but basically you can send a request to Alooma, hey, I want to schedule this query, and you can schedule it using a cron operation or a cron job expression, like run every Tuesday at 2 p.m., or you can just tell it to run every interval of hours. So I want it to run every 8 hours starting now. Alooma will perform these queries on schedule, will monitor them, will send alert if there are any errors, and will retry them.
Can we schedule batches?
So Alooma does not schedule batch loads in the sense that if we read it, and this is only half true, it really depends on the data source. Some data sources only allow batch reading from them. So let's say we are reading Google Analytics reports. These are given in a daily resolution. So Alooma, of course, will load a batch of a day every day. But if the data source supports streaming replication of the data, Alooma will also streaming replicate it into Snowflake. So it depends on the data source. And normally what Alooma does is Alooma will do its best to load the data as fast as possible. But if something is available as streams, there isn't an option to load it as batches instead.
Our next question is, actually someone asked, could you go back and explain the use of a staging table? Please give a bit more information about that.
Yeah, sure. So as you can see, there are two tables here. There is the salaries log and salaries table. Every data point that comes in will go into the salaries log table. And this table can have multiple versions of the same row. And we decide what is version of the same row using the primary key. So what we usually will do is we'll take the primary key from the source, if it has one, or it can be configured. But in that case, the source has a primary key, which is employee number. So every employee has the date that he has been employed, which is the from date and to date, and then the salary. So the same employee can have different records, and then they will go into the salaries log table. And then every interval, the normal interval we do it is every 15 minutes, but this can of course be configured. But for the sake of the explanation, let's say every 15 minutes, we would look at the salaries log table, and we will take only the most recent record from this table and push it into the salaries table. And if this record exists already in the salaries table, we will also check that the record that we are pushing is more up to date than the one that already exists there. So this ensures that the final table, the salaries table, in that case, will only have one version of each row, which will be matching one-to-one to the source, again, using the primary key definition of the source, but the staging table can have multiple ones. And this is actually also very useful to saving history. Let's say you want to see all changes that happen to a record over time. You can just retain the history for the log table forever. You don't have to, usually by default, we clean up the log table. We only save a couple days of history, but you can retain history for all time and actually have access not only to the state of the table as it is on the source, but also to all of the changes that have been going through.
All right, how does real-time sync work with Oracle as a source?
Yeah, so we support Oracle Log Miner, so we can actually, we can share from our documentation as well. But basically, we have a log miner that can read Oracle transaction logs. So we are getting every change that happens on the source, we'll get to Alooma. And this will be a real-time sync again. In that case, it will go into the staging table. We'll have a real-time view available, and will be loaded into Snowflake. We also support bulk reading from Oracle. So let's say I want to dump a table every 6 or 8 hours. So batch loading is also supported for Oracle. And it really depends on the use case if it's better to use batch loading or to use the log miner approach.
Okay, looks like we've got a lot of good questions. If a parent table source is rejected, source record is rejected, are all the child records rejected and reprocessed?
I'm not sure I understand the. So I hope I understand the question correctly, but the way I understand it, and if not, feel free to write in the chat, is that let's say we take a record that's coming from the source, we split it into multiple different records, and then one of these split records is being rejected, or the parent record is being rejected. So everything that goes into Restring Q goes in the raw format, except the child record. The child record will go in the processed format. Now there are two options here. Usually, when splitting a record, you're only trying to move over the child record, and then if one of them is being rejected, then the rest will go through and will not be reprocessed. But if one of the child record will be rejected as well, it will be reprocessed because it will go into the Restring Queue as a separate record. Usually, you need some kind of a code engine mechanism to avoid splitting twice the same record. So let's say you took a record, which is a parent record, you split it into multiple child records, and then it goes back from the Restring Queue or from the error queue into the pipe. You use some code to prevent it from splitting twice. Usually, it's using the metadata field that's called Restring Count, which means, is that the first time I'm seeing this record, or did I already see this record in the past? And if that was not a question, then feel free to elaborate.
All right, we'll move on to the next one. Is the Alooma engine on the Snowflake server, or is the engine outside of Snowflake? I'm trying to estimate the time it will take for a round trip for the data to go back to Snowflake.
Alooma engine runs outside of Snowflake. So Alooma will ingest the data to its own servers, will run the code engine, and then will push it into Snowflake. And again, usually in terms of frame stream type, the main factor in calculating the time would be how long would it take to copy a batch into Snowflake. And it could vary from seconds, from single-digit seconds to tens of seconds, depends on the data volume.
Okay, for Snowflake integrations, is Alooma recommending to transform data into S3 because there is a separate pipeline landing your raw data into S3 as well?
Yeah, so when copying, the best way to move data into Snowflake is to use S3 as an intermediary. And this is unrelated to the separate pipeline that's moving the raw data over. This is an optional pipeline just for if access to the raw data is needed. When moving data into Snowflake, again, the most scalable way is to use copy commands. These are using S3 just as an intermediate layer. The data is not being retained on S3 after it's being copied into Snowflake, but it's just for the purpose of Snowflake to be able to parallelize the load of the data.
Okay, good. Looks like we've got a couple more, just more general ones. What are the best use cases for Snowflake?
Yeah, so Snowflake is great for cloud-based analytics, and what's really great about Snowflake when comparing it to other solutions. So there are cloud analytics in general is a much more cheaper and a more economical way to provide analytics for the entire organization compared to, let's say, installing HP Vertica on premise or other analytics or Netezza, IBM Netezza. When moving to cloud analytics, Snowflake has two unique characteristics when comparing them to other options like Redshift there. The first is it's fully managed. So if you come from Redshift and you are used to things like vacuums and defining compression encodings, with Snowflake you don't need to do all that. This is a fully managed data warehouse as a service. The other very important thing to note is that you can separate cost and compute completely. So they are completely independent. And a very good use case for Snowflake is if you have a lot of data that you want to retain for all time and all of the past, and then on the other hand, you don't query this data very often. Because storing data in Snowflake in terms of cost is comparable to storing it on S3 itself. But you get an added bonus that if come the occasion you need to query the data, it's already available for querying. And this is because storage and compute are completely separated in Snowflake.
Okay, another question is, if I was using Alooma and Snowflake, and the Snowflake is based on credits, what would happen to my data if I run out of credits?
That's actually exactly what happened to us in our demo account. So I can show you. You can see that I will filter by Snowflake load error, and you can see actually the error. The monthly credit have been exceeded its quota, so we are out of credit. The data just ended up in the Restring Q. Once we resume the credit, we can click Restream, and the data will be loaded. So the data is safe in the Restring Q.
Okay, can you describe the software stack on which your product is built?
Yeah, so in terms of technology stack, Alooma is trying to use the best of breed technologies. Again, Apache Kafka is one of our cornerstones, as I mentioned, as our message queue. We are using, for processing and the code engine, we are using Apache Storm as a building block, but it's actually a heavily modified version of Storm, so I'm not sure it qualifies as Storm anymore. Restring Q is also based on Kafka, but the analysis is based on Elasticsearch, just to be able to provide analytics, easy analytics on the Restring Q as well. And then we have a host of other technologies to store the state, for the stateful processing part, or for the dashboard and monitoring, etc.
All right, next question is, what is the retention on the Restream Q?
That's actually configurable. By default, it's forever. It's okay. So there is how much data can be there and for how long it's being retained. So how much data can be there? Usually it depends on subscription tiers. And what we try to keep in the Restream Queue is to be able to keep at least 2 or 3 days of data from all sources. So let's say if the data throughput is 10,000 events per second, the Restream Queue will be big enough to retain data that's coming in for 3 days, because something really, let's say, again, you're out of credit and you didn't buy anymore, and all of your data is going into the Restring Queue. In terms of how long is it staying there, this is actually configurable. By default, it's forever. You can, of course, purge it, so whenever you want, you can clear it. For some customers with more sensitive data, we provide automatic time to live for the Restring Queue. Let's say they say, we don't want our data to live on Alooma, because the Restring Queue is the only place where data actually lives inside Alooma. Alooma does not store any data outside of the Restring Queue, it just passes it over. So they could say, we don't want our data to be stored for more than 24 hours, so please add auto purge for us. And then we would automatically purge records that are older than 24 hours. Hope this answers the question.
Our next question is, what differentiates you from other products such as Fivetran?
Yeah, great. So there are a lot of options in the market for data pipelines, and I would say that the places where Alooma shines or are different from other options is one, the ability to transform the data on the stream and not just copy paste it. So other options out there, you can get your data from A to B, but assuming you don't need any transformation at all, you don't need any modification of the data. And the other aspect where Alooma shines is real-time access to the data. I believe that Alooma provides the data as fast as possible, especially compared to some other options out there. And then security. I believe we are the only product in the market that is SOC 2 Type 2 compliant, that signs HIPAA BA agreements with the healthcare customers. So if security is important, this is also where Alooma would probably be a good choice.
All right, next question is, what type of alerting is available?
in terms of, I assume this is in terms of event allotment. Alooma pricing model is based on tiers, and the tiers can go as low as 100 million events per month, and as high as 20 or 50 billion events per month. So it's really, there is no limit, so it really varies. And we have some very, very big customers like OkCupid that are pushing really huge amounts of data, and some very small ones as well.
Sorry, I'm gonna just clarify that question they wrote again to clarify that one. So, um, what type of alerting is available? What kind of alerting in terms of notifications and monitoring?
Yeah, so Alooma provide email alerts, and they can, every error level can be selected to be sent. First of all, there is a digest that can be sent hourly or daily, and then for every level of errors, you can decide if you want it as it happens. For example, our recommended configuration is a daily digest and error as they happen, and then warnings and information in the digest email. And then this email can also be hooked into PagerDuty or other monitoring services. Now, in addition, all of the Alooma notification are API oriented. So there is an API query where you can actually query all of the things that appear here on the right side, and then you can pour them over some of our customers, and also all of the metrics in dashboard. So some of our customers move them into Datadog or any other monitoring, or Zabbix or any other monitoring tool.
Our next question is, which other data warehouses do you work with?
Yeah, so we currently work with Amazon Redshift, Google BigQuery, MemSQL, and MySQL as targets.
All right. Looks like next question is, do you have native auditing or data lineage?
Yeah, so we do hold audit log and transaction log on every operation that happens in Alooma. So any modification that happened to the data. By default, we don't expose this audit log. These are things that we can do, or that we do with our enterprise customers. But we do track that. We do track that.
All right. Looks like that was the last question. Um, on behalf of Yair and Alooma, we'd love to thank you and everyone on the line for joining us today. We hope you enjoyed the discussion as much as we did. We look forward to recording. Look forward to the recording of today's presentation, your email, and stay tuned for future webinars. Have a great day, everyone. Thank you.